So now that you've mastered graphing a parabola in the vertex form, which is a times x minus h all squared plus k, now we need to learn how to graph parabolas that are in standard form. So ax squared plus bx plus c. So in order to graph a parabola, you need to know the a, because that tells you whether you're opening up or down, and it tells you whether you're narrower or wider. And then you also need to know the vertex, so this hk value. So to find the vertex, there's two ways of doing it. Way number one is by completing the square. And way number two is a formula derived by completing the square, which is in some ways much easier to do, but less of a, let's say, creative process. So the first thing we're going to do is discover what it means to complete the square. In order to do that, I have to remind you what a complete square looks like. So if I do x plus 2 squared, that means x plus 2 times x plus 2. And it gives me x squared plus 2x plus 2x, and then 2 times 2 is 4. So if I collect like terms, I get x squared plus 4x plus 4. And if you remember way back in chapter 5, when we were talking about factoring perfect square trinomials, the first thing you had to do was recognize what makes something a perfect square trinomial. And it was that half the middle term squared, so half the middle term, which is always one of those OI terms, the outer inners, squared gives you that target number, or this last AC here. So this is a perfect square trinomial, x squared plus 4x plus 4. And what we're going to do is go from this into a factored form in one step. And you might have done this in chapter 5 already, you might not have, but the way that you do it is that you recognize it's a perfect square, and we're going to be making these perfect squares, and then you just take half that middle term, and that's your second half of your binomial. So if I have x minus 5 all squared, so if you were to do that quickly, you know the first term is going to be x squared, the middle term is going to be minus 10x, because it's twice these two multiplied together, and then the last term squared. So again, it's x plus 5 times x plus 5 minus 5, x minus 5 times x minus 5, so you get x squared minus 5x plus 25, and these 2 minus 5x gives you negative 10. But to go backwards, what I want you to recognize is that this is always a perfect square, and then you can take the square root of it to get this last term, and then put the sign of the middle term, or it's half of your middle term. Okay, so that's a little bit of a talk about, what it means to get a perfect square, and a little bit about factoring it. But in chapter 8, the extension is that we need to make these perfect squares. So we are going to make sure that half my middle term squared is this last term. So half of 4 squared is 4. Half of 10 is 5, squared is 25. So the first thing we're going to practice is just making perfect square trinomials. So to make something a perfect square trinomial, you take half the middle term, so half the middle term, and then you square it. So half of 14 is 7. 7 squared is 49. Now, to go an extra step further, I want you to also recognize that to factor this would be x plus 7 all squared. Half the middle term, right? Or you could think of the square root of the last term. For this one, to make the perfect square, you're going to take half the middle term, so half of negative 14, and you're going to square it. And again, you get half of negative 14 is negative 7. Negative 7 squared is still 49. Your perfect square, you're always going to be adding the perfect square. This one, however, when I factor it, instead of being t plus 7, it's going to be t minus 7 all squared. Pause the video, give this one a go. So hopefully you decided that this last number would be a 9, because half of negative 6 squared is 9. And then hopefully, if you factored it to x minus 3 all squared. So if you can do this, you can do creating a perfect square. Okay, or completing the square to find the vertex. So here's your actual steps to completing the square to find a vertex. So you're going to be given a trinomial, but this is not going to be a perfect square trinomial. Your job is going to be to make it a perfect square trinomial. To do that, what you do is you take your squared term and your number. If there's a coefficient on the x squared term, greatest common factor it out of these terms. Now this one has a 1, so we're good. Then you're going to do the magic. So you're going to take half that middle term, so half of -4, and square it, and get the magic number. This is the magic number that makes your trinomial a perfect square. So then what you do is you add it. So I've got x squared minus 4x plus 4, which we know factors to x minus 2 all squared. Great. Problem is, we can't just add 4 onto an expression. That would change its value. So instead what we do is we add 4 and we subtract 4. You always have to do both because I haven't changed the identity of my expression if I add 0. By adding 4 and subtracting 4, I've added 0. I didn't change the value of my expression. But the only part of it that is a perfect square is the x squared minus 4x plus 4. So this minus 4 is just going to come out of that bracket. To come out, you're going to multiply by this 1 and get written outside. So you're left with x squared minus 4x plus 4 being your perfect square trinomial. And then on the end, you have minus 4 plus 2. And then you simplify. You simplify by factoring, so you're going to factor x squared minus 4x plus 4 to x minus 2 all squared, and then -4 plus 2, oop, there's an error in here, should be -2. So then I know that the vertex of this parabola is going to be at 2, -2, and it's going to have a regular shape opening up. And so I could graph it as well. So let's just keep doing that process. Let's keep completing the square to find the vertex. So all of these ones that we're doing have a coefficient of 1, just to keep it simple. So I'm going to do another one with you, and then I want you to pause the video and try this one. So what I want you to think of is that this is what's going to create my perfect square trinomial. Then we're going to have this -9 on the end. So to create my perfect square trinomial, I'm going to take half my middle term. So I'm going to take half of 4, and I'm going to square it. Half of 4 is 2. 2 squared is 4. So adding 4 would create this perfect square. But I can't just add 4 to an expression. That would change the value. But if I add 4 and subtract 4, I'm not changing the value of my expression because I'm adding 0. What does it allow me to do? Well, I can factor my perfect square trinomial down to x plus 2 all squared. And then I can collect like terms. I can get -4 minus 9 is -13. That would tell me that my vertex is -2, -13. It would open up and it would have a regular shape. Okay, so if you feel good, try to pause the video and follow this process. So remember, when you're starting it, you're just creating your perfect square, and that +8 goes somewhere off to the side. So you're going to create your perfect square, and then you're going to add and subtract that number, and then keep going. So my hope is that you pause the video and that you're coming back. If not, that's okay if you stayed. Okay, so to create your perfect square, you always take half the middle term, so half of -6, and you square it. So -6 divided by 2 is -3. -3 squared is 9. That's my perfect square. If I'm going to add 9, I have to also subtract 9, so I don't change the value of my expression. Now I can factor this perfect square down to x minus 3 all squared minus 1, which tells me that my vertex would be at 3, -1. All right, you could pause the video here and go and try some of the ones that have a coefficient of 1 in front of them. So if you go to your textbook, section 8.6, just looking through your homework here, you can do number 7, number 8 I would skip, or number 9 I would skip, number 11 you can do, and then we go on, so you could do number 25, you could do number 27. So look all of the ones that have a 1 coefficient, and maybe just try this to start.